Section 3, Annuities, Future Value, and Sinking Funds. So if you would like to hear someone actually in the insurance world explain annuities, this is actually a good video. It's actually a little dry, but he does a pretty good job of explaining a lot of things in that. Okay, but I'm going to tell you everything you need to know, probably plus a little more. But if you want an additional explanation, there's that. So an annuity is a sequence of equal payments made at equal periods of time. Okay, so equal payments made at equal periods of time. So every month, or every year, or every quarter, something like that. That's an annuity. Now an ordinary annuity is where if equal payments are made at the end, bold, underlined, box, of equal periods of time and the frequency of the payments is the same as the frequency of compounding, then the annuity is called an ordinary annuity. So it's always at the end. Okay, so you'll see something like at the end of each month or at the end of each year. That's a really big deal. There's another type of annuity actually called an annuity due that we will get to at some point, and actually it'll be at the end of these notes, and it's always at the beginning. So for an ordinary annuity, this is at the end. All right, so example 1, consider a person depositing $100 at the end of each year for a period of 5 years into an annuity that pays 5% interest, compounded yearly. All right, so the thing I really want to point out, we're not actually going to find the answer to this, but the thing I want to point out is that the first year, it's at the end of that first year. So that $100 you put in the first year, actually you don't get interest on it for the first year. You get interest for the rest of those 4 years. So you get compound interest, 100 times 1 plus 0.05 divided by, it's yearly, divided by 1 to the 1 times 5. Actually, it's only to the 1 times 4. You only get it for those 4 years. Okay, so that second $100, see if I can use a different color, second $100 actually doesn't apply until the beginning of the 3rd year. So you only get interest on it for 3 months, or for 3 years. So 100 times, that's actually 1.05 to the 3. Next, the 3rd year, you get that money, and you actually only get interest on it for the last 2 years of this. So 100 times 1.05 to the 2. And green. 4th year, you don't get that money. You only get interest on that for the last year. So 100 times 1.05 to the 1. And then that last amount, that last $100, you actually don't get interest on that at all. It comes all the way down here, and you just get it back. Okay, so we actually have a geometric sequence that goes on here, and in general it looks something like this. The payment plus the payment with interest for over 1 period, the payment with interest in 2 periods, all the way up to 4. In our case, we had a 5-year period, and minus 1. Okay, so in general, that's what it looks like. And so we actually can use a geometric sequence to find or derive this equation that I'm going to show you. You're not going to have to do that, but you could do that. Okay, and I think it's in the textbook. So here's actually, if you do that, it comes out to be this. Now, another thing to notice is these brackets right here. Really, they're just parentheses. You can treat them like they're parentheses. So when you use your calculator, only put parentheses right there. All right. So future value of an ordinary annuity. So the future value, and this is a different letter than we did the last time. Okay, we have had A for our future value. S is also the future value. Okay, just specifically with annuities. Equals the payment R times, in parentheses, 1 plus I to the n minus 1 over I. Okay, so that is actually, like I said, it's derived from the previous formulas. It looks a lot like some of the other ones. Okay, but let's look at example 2 and use this formula. All right, Bethany Ward is an athlete who believes that her playing career will last 7 years. I want to underline these things. 7 years. There's our T value. Okay, to prepare for her future, she deposits $22,000. So her deposit, that's actually the periodic payment. Okay, so R is our payment rather than P. Okay, at the end of each year, that's totally important here. At the end of each year for 7 years, in an account paying 6%, there's our rate, compounded annually. So that means M equals 1. So how much will she have on deposit after 7 years? So we're finding S. How much she'll have on deposit? That is S, future value. All right, so appeal to this formula. S equals R, which is 22,000, times 1 plus, in parentheses up here, 1 plus R over M, so 0.06 over 1 to the 1 times 7 years, or time, minus 1 over 0.06 over 1. Now, let me point this out. The same couple of things apply. Okay, we still have that N is M times T, and that I equals R over M. Okay, so there's the equation. So if you actually type this in your calculator very, very carefully, you should get, once we round to the hundredths place, the S equals $184,664.43. Now, this is not a change, but as always, pause these videos as you're going through. Make sure you can do them, because that's kind of the thing. When you get to the end of the test or the assignment or whatever, you're going to have to be able to do it on your own. So make sure you're getting the same answer and that you're not just writing this answer down that I've got. Okay, starting with example 3, I want to show you a little more of the TVM Solver. So here we go. Find the accumulated amount after 11 years if $250 is deposited every month in an account paying 3.3% interest compounded monthly. So first 11 years, that's our T. $250 is deposited, so that's our payment every month. Okay, so that tells us that M is 12 times in a year. An account paying 3.3% compounded monthly. All right, so I'm going to fill in this table here. Okay, N is M times T. That's 12 times 11, which is 132. The interest rate, 3.3. The present value, which we haven't put anything in it yet, so it is 0. The payment, this is something that's kind of weird. In finance, payments that are made are negative. It's money flowing out from you, cash outflow. Okay, so it's actually negative $250 for the payment. Future value, we don't know that. That's what we're after. Payments per year is monthly, so that's 12. And compounding is 12 as well. And it was at the end of every month, so the end. All right, so if we put this in our TVM Solver, which let me just go and show you what it looks like on the Inspires. If you go to Scratchpad, Menu 8 for Finance and Finance Solver, you can actually put that information right here. And wherever you want your answer, so in our case, we're going to be wanting this right here, we're going to hit Enter. And it'll actually calculate what should be there. See how it has it highlighted? Okay, similar sort of thing for your 84 if you have that, or an 83. All right, so, but once we do that, we should get calculated out $39,719.98. $39,719.98. Make sure you make the payment negative right there. Otherwise, it'll tell you something like no sign change. That'd be kind of an issue there. Okay, example 4. Find the future value of an ordinary annuity if $9,200 payments are made and interest at 10% is compounded semi-annually for 7 years. So there's our payment, R. Interest is 10%, so that is our lowercase r. Semi-annually, so M equals 2. For 7 years, there's our time. Also calculate the value from contributions and the value from interest. So I'm going to fill in my TVM table. So N is 2 times 7. You get a total of 14 compounding periods when you do it semi-annually for 7 years. Interest rate is 10%, so 10. Present value is, again, 0. The payment is negative $9,200. We don't know the future value. Okay, we've been asked to find the future value, so I'm just going to put a big question mark there. We don't know that. Payments per year. Well, it says they're made, let's see, $9,200 payments are made and interest is semi-annually. Okay, so their payments are actually semi-annually, so that's twice a year. So 2 for payments per year and compounding per year, compounding periods per year. And the payments are at the, do they tell us here? Ordinary annuity. Okay, ordinary annuity means we have the end. So it is at the end of each. So when we put these in our TVM calculator, okay, we should get a value of S equals, which is the future value, $180,307.41. Okay, of course, rounding there. Okay, now, but that's not all we're asked. Okay, we're asked to find the future value. Okay, check. Also, calculate the value from contributions. That means how much did he actually put in, well, I say he, how much did we actually put into this account? Well, we put in $9,200. Okay, we did it semi-annually, so we did it 2 times a year, and then we did it for 7 years. So 9,200 times 2 times 7 is the total amount that's actually put in. That's the contributions. Go ahead and label that. Contributions. Okay, and that amount there is $128,800. Okay, so when it comes to that total amount, we've actually done most of the legwork there, but the interest is what we care about. So we'll subtract $180,307.41 minus that $128,800, and our interest should come out to be $51,507.41. So that's a lot of interest over 7 years. Okay, that's also a pretty high interest rate too. But the 3 things we were asked for are our future value, our contributions, and our interest. Okay, next we have sinking funds. Okay, now sinking fund is really just a particular word to mean what we've already been doing. Okay, it's a fund set up to receive periodic payments at the end of each period, and then it's called a sinking fund if that's the case. Okay, so usually this is actually if you're saving for something. You're putting money aside specifically for something at the end. Okay, it's receiving those payments, which, again, that's really the ordinary annuities we've been doing. All right, so example 5, experts say that the baby boomer generation cannot count on a company pension or Social Security to provide a comfortable retirement as their parents did. It's recommended that they start to save early and regularly, and that's just a good idea anyways. Okay, Nancy Hart, a baby boomer, has decided to deposit $200 each month. $200 each month, so there is our payment. Okay, for 20 years, there's our time, in an account that pays interest at 7.2% compounded monthly. So it's monthly, so M equals 12. How much will be in the account at the end of 20 years? All right, so we're actually going to use that formula we had before, the future value. S equals R bracket parentheses 1 plus I to the n minus 1, all divided by I. Okay, now remember, when you're using your calculator, the brackets, treat them like they're parentheses. They're just big parentheses. All right, so we are going to have R is $200, so S equals 200. I'm going to write parentheses, times 1 plus R over M, so 0.072, divided by 12, to the M times T, so 12 times 20, minus 1, and all that inside those big parentheses is 0.072 divided by 12. Make sure you do those nested parentheses properly. Okay, we have a big set out here next adjacent to the 200, and we have a couple of smaller sets in there. So however you type this in, you should get $106,752.47. Okay, now because you are learning how to do this, if you're not getting this, you need to make sure you do these on your own, these problems. But if you're not getting the same answers I am, then you need to take a step back, and we just need to figure out where you're doing something incorrect. Okay. Now, I will point out right now that anytime whether you do it by hand or whether you do it with, well, that's really the only way you do it. If you do it algebraically, then you can actually use the TVM to check. And so sometimes, actually, in the future, you'll be told, do it algebraically. Sometimes it'll be, do it with the TVM. Sometimes it'll be, do both. So you need to be familiar with both of those, but using the TVM is a good way to check that. All right. Part B on example 5. Nancy believes she needs to accumulate $130,000 in the 20-year period to have enough for retirement. What interest rate would provide that amount? Now, I would actually not ask you to do this part by hand. You wouldn't be able to do it. Okay, so we're definitely going to use our TVM. So we want to accumulate $130,000. That is going to be our S, our future value. So we can fill that in. Okay. in the 20-year period, there's our time. So 20 is our time. Let's see. And we actually need some information from that first part. So let's see. It was 7.2%. No, that we're wanting to find that. So forget that. Depositing $200 each month. There we go. So $200 a month. Okay, that's important. So our payment is negative $200. Okay, it's monthly. So we have M equals 12. So 12 times 20, which is 240. Okay, our interest rate, we don't know that part. Our payment is the negative 200. Oh, I wrote that in the wrong place. Negative 200 is our payment. Our present value, we don't know. Well, we do. She hasn't put anything in that account yet. So the present value is 0. Payments per year, it's monthly, so that's 12. Compounding is 12. And we are still at the end because that didn't change from the first part. She's putting that money in at the end of each month. So, end. And if we put that in our TVM solver, we actually would find that this number right here is 8.79%. Okay, so our rate is 8.79%. Okay, part C. Find the interest rate needed to accumulate $120,000 with monthly payments of $500 over 15 years, compounded monthly. All right, so we've got $120,000. That's what we're accumulating. So that is our future value, $120,000. With payments of $500, so that's negative 500 is our payment on R. So negative 500 over 15 years, compounded monthly. So M equals 12, and there's our time. So we have 12 times 15. Now our interest rate, we are finding that. We don't know that. Present value is 0 because we haven't put anything in it yet. Payments per year, it's monthly, so 12. And we are still at the end of each month because they actually didn't say anything else. We're assuming this is a sinking fund. But in the future, assume that it is an ordinary annuity unless you're actually told otherwise. That's just going to be a safe thing. Okay, we have this other kind that's the annuity due. We'll worry about those when we get there. So if we calculate this, we should get 3.69%. There's our rate. Okay, next we have sinking fund payments. So if we didn't know the payment, there's a specific formula for that. So it's this one, R equals S times I over 1 plus I to the n minus 1. All right, so if we just want to know the payments, if we know everything else, okay, we just want to know the payment, this is a good thing to use. In fact, we're going to use this with amortization here in a little bit, or in another section actually. So suppose Nancy cannot get a high enough interest rate to produce $130,000 in 20 years. To meet that goal, she must increase her monthly payment. What payment should she make each month? So what we need to do first is actually get some information from that previous example. Okay, it's 7.2%. Okay, and that's from 5A. I think that's actually all we're going to need from there. All right, so we've got a monthly payment. So it is M equals 12. We want to produce 130,000. So that's S. In 20 years, that's T. Let's see. Okay, we don't know the payment though. Okay. So we will use this formula right here. We just got R equals. So the payment is $130,000 times the interest rate, which is going to be 0.072 divided by 12, all over 1 plus 0.072 over 12 to the n, which is going to be M times T minus 1. And if you notice, this equation is really just a rearranged version of the one we had earlier. And so when we actually produce a number out of that, solve that algebraically, we should get, actually, I don't know. I didn't do this one yet. So let's see. That is going to be fraction, $130,000, parentheses, 0.072 over 12. All right, parentheses, 1 plus 0.072 over 12 to the 12 times 20 minus 1. $243.55, rounding that. So that's the payment that she's going to make each month. So originally she was saying she would deposit $200. So she's going to have to put in a little bit more than that. Not a whole lot, but a little bit more than that to get there. So from 200 to 243. And that'll accomplish her goal of reaching $130,000 in 20 years. Right, number 7, we're going to use the TVM. Find the payment needed to accumulate $8,500 with an interest rate of 8% compounded annually, with payments made at the end of each period for 7 years. So the end tells us we are using ordinary annuity. 7 years is our time. $8,500 is it needs to accumulate to that. So that is our S value, our future value. Okay, with an interest rate of 8%, so that's R. So 8. Compounded annually, so M equals 1. So compounded once, payments once. 1 times 7 years. Okay, so N is 7. Present value is 0. We haven't put anything in it yet. The payments, what we want to know. Now remember, this is going to be negative when we do it in the TVM. Okay, it's going to be negative, so we'll ignore the negative because it's the amount that's going out of our cash. So when we actually work that out, we get $952.62. So there's our payment. Okay, example 8. Matthew Pasteur is saving for a plasma HD TV. At the end of each month, okay, he puts $100 in a savings account. So that's how much he's putting in. Okay, so that is actually our deposit, our capital R, our payment. So minus 100 goes down there. At the end of each month, that pays 2.25%. 2.25 is I. Compounded monthly. So that means M is 12. Go ahead and fill that in. How much is in the account after 2 years? So there's time. So we have 2 times 12, 24. And we'll do a present value of 0. We don't know what that is yet. We want to know how much is in the account after 2 years. Okay, so we want to find that future value. So I'm going to use the TVM solver. If we work that out, we get $2,452.47, which is not a phenomenal amount considering he's putting $100 in there after 2 years. So we really need to see how much he actually put in there because we don't know straight from this. Okay, so that's where the contributions, how much did he deposit? Well, he put in $100 12 times a year for 2 years. So 100 times 12 times 2. So he actually put in $2,400. There's his contribution. Now, that's why I said it wasn't a real phenomenal amount. There's the accumulated amount. There's the contribution. Because he only got $52.47 in interest. Well, he's got 2% interest, and he's not putting in a whole lot. So that would explain why that's the case. But there's our interest. We subtract the 2 and find that. Okay, example 9. Vicky, I don't know how to say her last name, Kakunis, sells some land in Nevada. She will be paid a lump sum of $60,000 in 7 years. Until then, the buyer pays 8% simple interest quarterly. So this is not an accident. It says simple interest right there. So part A just says find the amount of each quarterly interest payment on the $60,000. So just the interest is all we're asked for. The amount of each interest payment. So we are going to take the $60,000 times 0.08. And one thing we've got to include in here is the time. Well, it's a quarter of a year, so it's actually 1/4 there, since it's simple interest. And that'll be our interest payment. So the interest here is actually $1,200. That's just the interest every quarter. Okay, not exactly a real great amount when you're paying this back. All right, so part B says the buyer sets up a sinking fund so that enough money will be present to pay off the $60,000. The buyer will make semi-annual payments into the sinking fund, the account pays 6% compounded semi-annually. Find the amount of each payment into the fund. So the buyer is being smart here. So they don't want to have to deal with just the interest payments. They're going to pay off the entire thing in that amount of time. How long was it? 7 years? Okay. So I'm going to use the TVM here. So I have $60,000. That's how much the accumulated amount. S should be the future value, 60,000. Okay, the payments is what we're trying to find, so we'll leave that blank. Present value is 0. Okay, interest rate is 6%. Compounded semi-annually, so M equals 2. That tells what the last two boxes are. And let's see, what else are we looking for? Payment and N. Okay, so M times T. So we know it's over the course of 7 years. So we have 2 times 7, or 14 total payments. All right, so we can use our TVM. And let's see, does it say anything about the end of the month? It does not say, but it does say it's a sinking fund, so that tells us it's the end. All right, so if we calculate this in the TVM solver, we get that our payment, is negative $3,511.58. That's going to show up as negative again because that's actually money that's coming out of you. Okay, it's your cash outflow. So we'll ignore the negative sign there. It's going to be $3,511.58. All right, now pretty quickly, these last bit of notes, we're going to talk about annuity dues. Okay, annuity dues. Okay, if equal payments are made at the beginning of equal periods of time, and the frequency of payments is the same as the frequency of the compounding, then the annuity is called an annuity dues. The only difference to make note of is that it is the beginning of those equal periods. Okay, it's the beginning of those periods. So the only thing that's going to change as far as us using our TVM solver is making sure to select begin at the end. Okay, so you do have this formula. Again, be prepared to do any of this using the formula or the TVM. We're not going to deal with this a whole lot, but you should know that there's the formula right there. Okay, S equals R times 1 plus I to the N plus 1 minus 1 over I, and then outside the parentheses minus R. This actually, well, the way it works, we can go back to the beginning and show you how that works again, but every amount that you put in there gains interest in some way, compound interest. Okay, that's really how this is going to work. So I'm going to go ahead and fill in the TVM. We have person deposits $100 at the beginning of each year. Okay, so beginning of each year. $100, that's our deposit, our payment. So payment, negative 100. Beginning of each year, we got that. For a period of 5 years. Okay, so time is 5, and it's compounded yearly, so M equals 1. So N is 1 times 5, or just 5. Interest rate, so it's an annuity that pays 5% interest rate. So 5 right there. Our present value is 0 again. Future value, we do not know. The payments per year, it's yearly, so 1 and 1. And we can use the TVM to tell us that the future value is $580.19. And there's our future value for that. All right, example 11. Example 11, find the future value of an annuity due if $750 deposits are made at the beginning of each month. Okay, there's our deposits. That's our payment. The beginning of each month, and interest at 5.9%. There's our R, our interest rate. It's compounded monthly for 15 years. So there's T, and there is also M. M equals 12. Also, calculate the value from contribution and the value from interest. All right, so N is M times T, so 12 times 15. I don't know what that is offhand, but when you type it out in the calculator, you'll actually figure it out. I want to say it's like 240. Okay, the interest rate is 5.9. Present value is 0. Payment is negative 750. It's coming out of our pocket. Future value, we don't know. Payments per year, it is 12 times. It's monthly. So 12, 12, and beginning. So when we put that in, we should get $217,328.08. Right. So there is the S, our future value. The contributions, we put in $750 12 times a year for 15 years. So 750 times 12 times 15 will give us the contributions of $135,000. Okay, there's our contributions. And the interest will take the value S minus the contributions, and that gives us $82,328.08. Of course, rounding. All right, so there it is. There's our future value. There's our contribution. And there's our interest. And we're going to do the almost exact same thing for 12. Find the future value of the annuity due if $1,500 deposits are made at the beginning of each semi-annual period, and interest at 5.6% is compounded semi-annually for 11 years. Also calculate the contributions and the value from interest. All right, so annuity due, there's our deposit, R, capital R. All right, there's beginning of each semi-annual period, so that means M equals 2 twice a year. Interest, lowercase r, 5.6, compounded semi-annually for 11 years. There's our time. All right, so N is M times T, so it's 2 times 11, or 22. Our interest rate is 5.6. Our present value is 0. Our payment is negative $1,500. Okay, our future value, we want to know that, don't we? Yes, we do. We want to find the future value. All right. So, next we have payments per year. Well, it's semi-annually, so those are both 2, and it is at the beginning. Again, using the Tvm Solver, we should get $46,034.09. Okay. Now the contributions, $1,500 twice a year for 11 years, brings us to a total contributions of $33,000, bringing our interest to an amount of $13,034.09. Okay, and those are the 3 things we were asked for: future value, contributions, interest. All right, that brings us to the end of section 5.3 on annuities, and we'll pick up with annuities next time as well.